Hi, welcome to Chapter 8. Chapter 8, we're going to get into this new thing called arrays, and arrays are a great way for us to create a variable, but it holds multiple items. Okay, so probably the best way I like to explain it is we're going to create a variable, and that variable is going to be a bookshelf. Okay, so let's just think of a square bookshelf, a rectangle bookshelf, and it's got no shelves in it. Okay, so what we do is we declare that bookshelf. It's an empty bookshelf. We declare it as an integer, as a real, string, whatever the case may be. We can declare it as a Boolean. We can declare it as anything. But then we need to tell it how many bookshelves are going to be there. And now the great thing about that bookshelf is I now number those shelves 0, 1, 2, 3, and 4, which is now 5. I now have 5 bookshelves. Now if I need to get to a specific shelf, I just need to refer to that shelf by its number. And that's as simple as an array gets. Okay, so the first part of the chapter, what it talks about is we're going to declare 3 variables called employee 1, 2, and 3. And then I'm going to come through and I'm going to say display the name of employee 1, we get the employee name. Input employee 2, we get the name. Employee 3, we get the name. So what if I had 15 employees? What if I had 20 employees? Do I declare 20 different variables, employee 1 through 20? No, that's where arrays come in. I can declare one variable, and so here's how we do it. So I say declare integer units, and I put a left square bracket and then the number of elements, that's the term we use for the number of items in an array, the number of elements in that array, and then a right square bracket closing that out. Okay, so here I have declare string names 50. Here I have a constant integer, size equals 10. This is kind of a so when we declare an array, we want to avoid using the actual numeric number to declare it. We always, again, want to use a variable. In this case, we'll want to probably most always use a constant to declare the size of our array. And once we have that constant in there, we can then go ahead and then basically declare array. Now the great thing about doing that is if I need to increase the size of that array, I can do that by just changing the constant. That's the great thing about constants, is it allows us, it's a variable that's not allowed to change, but we can physically change it and then recompile it and run the code again. So again, this is basically our bookshelf. They're going sideways. I'd rather go rectangle. But so we declare, so we've got an empty bookshelf. It's going to be called numbers. And then when I basically put this numeric value, in this case this numeric constant called size, the size is equal to 5, it automatically puts in 5 bookshelves. Okay, now the bookshelves always start with 0, so we got bookshelf 1, bookshelf 2, bookshelf 3, 4, and 5, but really they're numbered bookshelf 0, bookshelf 1, bookshelf 2, 3, and 4. So if we were to then load those, I would basically say set numbers, that's the name of the array, element 0, it's inside of the square brackets, I put 20. Inside the square bracket, 1, 30, 2 is 40, 3 is 50, and 4 is 60. So this bookshelf now looks like this. The first bookshelf, which is bookshelf 0, has a 20, bookshelf 1 has a 30, bookshelf 2 has a 40, bookshelf 5 has a bookshelf 3 has a 50, and bookshelf 4 has a 60. Okay? So if we want to output the array, same exact thing, just like the input, is we would basically, so let's just go ahead and take a look at the code here. Okay, so we look at program 1. So this is what it's going to look like in Raptor, and this is kind of what it's going to look like in most programs as well. So I create a size variable. It's an integer data type. It's a constant. and we're going to say we're going to then declare our array called hours. And how many elements in that array? Well, whatever size is, which is 3. So this is a 3-element array. That's an integer data type. I then say enter the hours worked by employee 1. We get those hours, we throw them into 1. Get the hours worked by employee 2. We get the hours, and we throw that into element 2. Now, this is where Raptor and other programming languages are different. Raptor always starts with 1 as far as their arrays. Once you get to another language like VB or Java or Python or different languages like that, they always start their arrays with 0. So just keep that in the back of your mind. Realize that we're going to be always starting with 1. And the book always talks about starting with 0, but we're always going to be starting with 1. Okay, so we throw the hours into element 1. We throw the employee hours into 2. We pull the employee's hours into 3. Then I go and display those hours. I put hours 1, put hours 2, put hours 3, and it will display those hours. So very easily, I run this. They worked 40 hours, they worked 43 hours, and they worked 36 hours. Now we're going to input those. There they are, 40, 43, and 36. Something I just learned last week. I've been using Raptor now for a couple years. This slider up here is the speed on which it will execute. So if you really wanted to sit down and watch this process go item by item by item, you can make it slower or you can make it super fast. So if I go through this again by going through that little slider right there, boom. Now you can see we couldn't even watch it run. Now if I really slowed it down, we can actually watch this program execute. It's like watching paint dry. Okay, so I'm going to speed this up a little bit just so that. So anyway, so the point there is we don't have to have 3 separate variables. We have one variable that's an array, and it can hold multiple items. Now, what if I tried to put something in element number 4 in this case? I've only got 3. Well, what we're going to get is an error called array out of bounds exception. It says your array can only hold 3 and you tried to put it in the 4th position. There is no such thing as a 4th position. You're out of your bounds, so that will actually cause the program to blow up. Okay. Yeah, so again, they even put it 40, 20, and 15, and basically it spit out 40, 20, and 15. Now, let's do this. Now let's open up the next array, or next program with the array. And what this one's going to do is now it's going to include a loop. So here I've got a series of 10, and it basically we initialize to 0 because it is an integer data type. We create an index of 1. We create a for loop. So I've got an index. Well, once the index is greater than 9, we're going to basically get out of this loop. Because remember, we always are a do until we do this loop until it becomes true. Okay, so we have our index. We come in here. We then say series index. We put 100 into there. Okay, and then I say index equals index plus 1. Okay. So what are we doing here? Well, it looks like we're just going to make these 10 items equal to 100 is really all we're going to do, right? So is that what they want us to do? Set each element array to 100. Okay. Okay, 0 to 9. Yeah, so once it's greater than 9, which is 10, we're going to back out. So how many times is that going to happen? I'm curious. Ah, now do you see the mistake there? The mistake there is we made the index only greater than 9 because we were expecting it to be 0 to 9. So what we need to do is we need to change this guy to be greater than 10, because you'll notice that we set our array to 10 and it allowed us to have 10 elements. We never filled that last one, okay, because we were expecting it to be 0 to 9, but a Raptor only allows us to do, can we do a 0? Let's see if we can do just a 0 element. Yeah, so it says we can't use zeros on array index. So that's kind of the downfall to Raptor as far as getting it to be close to other languages. But again, Raptor allows us to work through the logic of our building a program, get through the logic, and then we basically apply that to a program. Okay, so this should work fine now. Again, the nice thing is it shows series, which is the name of our array. It shows the brackets. We can actually increase that. We know it's a size 10, so we run it again. We can watch each element get loaded. Boom, we get out. Now, if I said greater than or equal to 10, that would basically get out at 9 as well. But if I made it greater than 11, then what would happen is we would basically get the out of bounds exception. Okay, so now let's take what we did in 8.1 and combine it with what we did in 8.2, and now we're going to basically get the employees information, but we're going to use loops to basically get it, as opposing to say, give me employee 1, give me employee 2, give me employee 3. So let's take a look at that. Okay, so as you can see, the first part is the same exact, except till we get to this, we're going to have two loops. One loop's going to get for input, one loop's going to be for output. So for this loop, we basically have our index. While index is, once the index is greater than size, we're going to basically get out. We get the hours worked by employee number, and we go ahead and put the index. Okay, so that way there the index is first going to be 1. So let's say give me employee 1, and the next index is going to be 2, 3, and then we're going to come back and we're going to set the index to 1, and we're going to loop back through. This time we're going to do the same exact thing. We're going to do this loop until the index is greater than size. So we're going to display the hours for each of those employees, and we're going to add 1 to the index for each one, since it's a for loop. So very easily we come in, so I can actually increase this hours so we can see each element. So they worked 40, the next one worked 43, and notice it's saying enter the hours worked by employee number 2. It's using that index to basically show you what employee that is. The last one works 36. And so it will display 40, 43, and 36. Okay? So as you can see, as opposed to, so the great thing about this particular loop now is this program is I could change this size to 4. I could come in here and say, what, we're going to change that constant to 4 now. We got 4 employees, and I basically run it. This time employee 1 is, let's say, worked 38 hours. Employee 2 worked 40. Next worked 42 and 35. It's going to display 38, 40, 42, and 35. So that's the great thing about this, is we just basically change the constant, and the program will run for how many employees you have. If you have 20 employees, you type in 20, change that constant to 20, and now you've basically, this program runs just fine for 20 employees. Okay, I want to change it back. Okay. So here's the end of Spotlight. It says processing array elements is no different than processing other variables. In the previous programs, you saw how you can assign values to array elements, store input in array elements, and display the constants in array elements. So Megan owns a small neighborhood coffee shop. She has 6 employees who work at the baristas. All of the employees have the same hourly pay rate. Megan has asked you to design a program to allow her to enter the number of hours worked by each employee and then display the amounts of the employee's gross pay. Okay, so we've seen this before where we basically looped through and basically did each employee. Now what we're going to do now is we're going to use arrays to basically store that information. Again, so let's take a look at 8.4. So here's the size of my array is going to be 6, so I create a constant integer of 6. I've got hours. Now hours is going to be the hours for each employee. How many employees are there? There's going to be 6 employees, so let's see the size. So right here I build my bookcase, and then the size puts each individual shelf into that bookcase. So now I've got my bookshelves, and I've got them numbered, and in Raptor they're numbered 1 through 6, and all the languages would be 0 through 5. Just again, keep that in the back of your mind. I've got my pay rate, which is real, my gross pay, which is real, and I set my index equal to 1. I go ahead and set my decimal places to 2 as well. So then I loop through, and I get the hours for each employee. And I do that until the index is greater than size. And then I get the hourly pay rate for each, and then I say here's each employee's gross pay. I reset my index to 1 because I'm going to go back through my for loop again. And I'm going to do this until the index is greater than size. Gross pay is equal to the hours. Okay, the hours is my bookcase. I need to grab that shelf and then multiply it times the pay rate, and then basically just put that in the gross pay, and then I display the gross pay for that employee. I increase my index, and I come back around and do that all over again. So again, this is nothing we've not seen before as far as the looping process. The only difference is now we're using an array to store the hours for each employee. Instead of having a variable for each employee, I just got one element or one variable, but it's an array that can hold, in this case, 6 different items. Okay, so very easily I come in here. So you know what, I'm going to stop this for a sec. I'm going to move that precision down here where we display the employee. I'll put it right here before this loop. And the reason being, as you just saw, it said employee 1.00. I don't want to display that. I wonder if I could do this. Put a floor in there. Wonder if that would work. Let's see. Let's experiment. Okay, so it comes in. Now it says employee 1, so they worked, let's say 36 hours. Next employee 2, worked 38 hours. Employee 3 worked 40 hours. Employee 4 worked 42 hours. Employee 5 worked 30 hours. And employee 6 worked 28. Okay? So enter the hourly pay rate. They make $12.50 each. Yeah, it's not working. Yeah, notice since I have that precision in there, I was trying to basically use the floor. Remember, floor will basically just show it as an integer, and it flat out did it? Yeah, that's the problem with the precision in Raptor, is it converts all numbers into 2 decimal places. Okay, so you can see employee 1.0 made $450, $475, $500, $525, $375, and $350. Again, we had one variable, but that variable could hold, in this case, 6 different items. Great thing about arrays. Okay, now we can create an array and load it at the same time. For example, here I've got a constant integer size 5, so I've got 5 elements to this array. Then I declare an integer numbers, so the name of my array is called numbers, and I've got the size of 5, and it's going to be equal to 10, 20, 30, 40, 50. Right there, I created the array and loaded it at the same time. So this put 10 in bookshelf 1, 20 in bookshelf 2, 30 in bookshelf 3, 40 in bookshelf 4, and 50 in bookshelf number 5. Okay. Here I create a integer size 7. I declare a string variable called days, and again it's an array, so it's going to have how many elements in it? It's going to have 7. And there I load double quote Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. They're all separated by commas. Okay. Here I've got a constant integer size equal 5. I then declare my numbers by size, and then I can set numbers 5 equal 99. Now again, in Raptor, this is going to be fine, but in all other languages, set numbers 5, because remember, in all other languages it's 0 through 4. Doing that is going to cause an out of bounds exception. So it says because array subscripts start at 0 rather than 1, again, tongue-in-cheek here, you have to be careful not to perform one-off errors. Okay. Let's take a look at 8.5. So, here we've got our size equal to 100. We've got values size equals 0. So we initialize our array, and we go ahead and create our bookcase, and then we basically put in 100 shelves. We've got count set to 1. We've got number set to 0. We've got index set to 1. It says enter the number -1 or to quit or get a new number. And so basically we've got, we're going to loop until numbers equal -1 or count is greater than size. If that's false, we're going to come in here and say values is the name of our array. That particular count is equal to whatever number is basically entered. Okay, so right here we've entered a number. We keep looping through it. That comes basically happens. Now here's the thing we're talking about is, are we going to go through this thing 100 times? No, we'll probably go through it 5 or 6 times and stop. That array still has 100 bookshelves. We've only filled 5 of them. So in this particular case, we're going to go back through this for loop. How many times are we going to do the for loop? How many ever count we went through? Because every time we went through, we counted 1. If we got out too early, we don't want to go through every element in the array, and I'll show you what I mean by that. So we run this. First, before we go on, if I increase this, look at how many bookshelves there are. There's 100 bookshelves here. So I type in, we'll say 50, 30, 25, 12, and then -1. So we basically got out, and now it's going to basically go through the elements. How many elements are going to go through? Well, what is our count? Our count is 5. Our index is 5. And that's basically how far it went. Now, our count is 5, but we only entered in 4 numbers. So, and we have to know that going in, because why? Why is count set to 5, but we only entered 4 numbers? Well, remember, every time that we went into this, we added 1 to count. And then right here is where I ask to get that -1. When I typed in -1, we've already given count 1 extra digit. We've counted it 1 extra time, even though I typed in a -1. So notice down here I said, while the index is greater than count -1. The reason I do that is because I know I basically added 1 to count, knowing that I typed that -1. Okay, so let me kind of explain what I mean here. So I'm going to put a break right here, and then let's run it again. Okay, so I've got my 100 elements in my array. They're all set to 0. Then it's asking me, I'm not in the loop yet, but it's asking me to enter a number. So I type in a number, and so it loads that first element right here. It loads that first element with that number. It adds 1 to count. Now it's asking, enter another number, or, so let me do that. So enter another number. So I type in 40. And what it did is it added 1 to count. So count is now at 3. Because up here I had count set to 1. When we went into the loop, we added 1 to count. Now we're at 3. If I type in, so let's just step through it one more time. So I type in 25 because I'm actually at my 3rd number, right? So my count is at 3. Click on it. Count is now at 4 because I'm now going to this. I've now entered 3 numbers and I'm ready to enter my 4th number. Except this time I'm going to type in my -1, and guess what? It still went in, and that count was set at 4. Well, I don't have 4 elements in my array, I only have 3. So in order to make sure that this loop does not go out of bounds, because if it did, it would have got a 0, because my 4th element was a 0, we went ahead and said count -1. I only had 3 elements, not 4. So I had to basically account for that. Okay. Now this is something we can't do in Raptor, but this is something we can do in other languages, and it's called a for each loop. Now the great thing about a for each loop is it knows how many elements are in your array. So I can say for each variable in array. So if I have a variable called var and I have an array called an array, it knows right now, it knows how many elements right there are in that array. So how many times is it going to go through this loop? It's going to go through this loop how many times there's elements in the array. Now, here's how it works. Is the first time it goes into this loop, it grabs element number 1, the very first element, and throws it into var. The next time it goes through the loop, it automatically grabs the next element and throws it into var. Next time through, it grabs the next. So it's doing this for us automatically. So we don't have to create an index. We don't have to do all that stuff we do with a for loop. We just say for some variable in array. And that the loop process automatically grabs the first element, throws it into that variable. Next time through, it automatically grabs the next element. So it does a lot of the work for us. Now again, the bad thing is for us is we don't have that ability in Raptor, so we'll have to continue to use a for loop for now. But just realize that that is going to be available in these other languages that we move on to. Okay, so In this particular section, we're going to talk about searching an array. Now, right now, the only way that we can search an array is what's called sequentially. That means I start at element 1, 2, 3, 4, and I'm searching for a specific value in that array. So, in this particular case, we set a Boolean to false. We set our index to 0. In our case, would be 1. And if found, so here is our check to go into our loop. So here's our loop process. If found is equal false, and the index is less than size minus 1, okay. Again, in this world, they always start with 0 and go to the size of the. So okay, in this case, let's say the size of our array is 5. We can't go from 1. We can't go from 0 to 5 in this case. We always have to start with 0 in this world and go to 4. So they always say size minus 1 in this case. So just keep that in the back of your mind. So we come in, we say, if the array index is equal to search value, we go ahead and set the found equals true, else we set the index equals index plus 1. Okay, so once we come, so if it was set to true, we come back, this is going to cause us to get out of that loop. Okay, so let's take a look at program 8.6. So here I have my constant set to 10. Am I even using that? Apparently I'm not. Well, here's what we need to do. I need to set scores. I forgot my 0. Nope, I need to make that, sorry, I need to make that equal to the constant. There we go. I'll put a comment. Okay, so I've got my constant here. I create my array and then I load the array. So here's score 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I set false equal found equal to false, which is a Boolean. Let me change that as well. Boolean data type. I set my index equal to 1, and then I go through my while loop. Found is equal to true, or index is greater than size, we're going to drop out of that loop. If it's not, we're going to come in and say if score index is equal to 100, if it is, we're going to basically set found equals true, else we're going to set index equal to index plus 1. I'm going to keep going through that loop until one of these becomes true, and then we come down here. If found equals true, if that's true, we're going to say you earned 100 on your text number. That should be test. I must have had fat fingers when I typed this in. Anyways, you earned 100 on test number and whatever index that is. Okay, whatever test number. Okay, so we run this. So let me pause this for just a sec. So here we are, we're in index 3, which is 98. Notice that found is set to 0, which is false. And as we go through this guy, look at that. So found got set to 1, And I'm going to slow this way down and try this again. So we've got our array set. Now I'm going to go in here. Can we come in here? We check to see. Here's 4, so it's going to find 100 right now. So it did. So it set found equals true. We then drop out of the loop. We set a found true. We go ahead and display. You earn 100 on test number 4. So we know. Now again, if this was a regular array, we would have to add 1 to the index. So it would say test number 4. Because if we didn't, it would say test number 3. Because remember, the elements start with 0 and would go to 9. Okay. So, pretty neat. We loaded an array, and then we searched for it sequentially. That means we went line by line by line. Now let's use a string array. Again, we don't have the ability to create an array and load at the same time. We have to do that kind of manually in Raptor. So here we've got our size equals 6, and again we screwed up again. We needed to create the array first. So we're going to say names size equals 2 double quotes. Okay, and then we come in and load it with these names: Ava Fisher, Chris Rich, Georgia Gorgon Pike. Is that right? Gordon Pike. Apparently I had really fat fingers that day. Gordon Pike, Matt Hoyle. Okay, and then Rose Harrison and Giovanni Ricci. Found equals false. So pretty much the same exact thing as we saw before. We're going to do this loop until found equals true or the index is greater than size. So if name is equal to name search value, if that basically becomes true, it'll cause a scalar loop. Else we'll go all the way through this thing and never basically find anything. But here in this case, instead of looking for a specific number that's in there, we're going to ask the user what to search for. Okay, so let me pick an easy one. We'll play Matt Hoyle. Sounds good. So I run this. And I'll type in Matt Hoyle. So it comes through one at a time. So there's all the names. Our index is set to 2, so it's looking at Chris. It's 3, it's looking at Gordon Pike. Here it comes to 4, which is Matt Hoyle, and whoop, it finds it, found equals true, so it's now at 1. Then it comes down and says found equals true. It says that name was found at subscript 4, and sure enough, there it was at position 1, 2, 3, and 4. Now again, if this were a Java or a VB or Python, we would basically we would say down here that name was found at index +1, because that would say it was found at subscript 3. Okay. Let's take a look at a 8. Yeah, I can't believe we didn't do that. So we have names. Now, what are we doing different this time? So we've got our array of strings, and we set her false. Now this time we're saying found equals true or index greater than size. This time we're going to say contains. Okay, so now here's what we're looking for. Let's say I'm looking for a word Matt. I'm looking for the person named Matt. Okay, so up here I've got, that should be Gordon. So here I could just type in Matt. Now here's the great thing. This is using a built-in function called contains. Notice we're using a call function right here, and it has contains. It's not a built-in function, it's a function we wrote. So notice over here I go over here to contains, and here I basically am doing what with this? Well, let's take a look. I'm bringing in a search value, and I am bringing in the array element, and then I'm outputting same. Okay, so what is same? Same is basically a Boolean. I need to basically say that. This is a Boolean. Here is my numchars. So my numchars is a variable. You know what? We need to declare that. I don't know why we didn't declare that. And now again, length of is a that is a built-in function for Raptor that says, hey, I can look at something and it will tell me how many items there is. Now, the great thing about this though is this is the array element or search value. What is search value? What are we passing to search value? Let me look at that real quick. So search value is right. That's what we typed in that we're looking for. Okay. And so what we're doing here is, so I'm looking at I'm looking at the length of what we typed in. So if I just type in M-A-T-T, Matt, it's going to give me back 4 characters, and that 4 is going to be put into numchars. Some index of 1, I go through my loop. Same. What is same? Same is basically false. I'm going to do this until same is equal to false, or right now same is true, or index is greater than numchars. That should probably be false and then true, right? Yeah, let's change that. I don't like that either. I don't know what I was thinking the day I wrote this. That sounds better, because if they do equal, they are going to be the same. So that really makes so much more sense. Okay, so I'm going to do this until same equals true, or we basically run out of number of characters. So then I do a search value index, which is basically my array that I brought in, equal array element. Now what is array element? That is, array element is a, what do we pass in? We are passing in what? The search value and the names. Okay, so that is the actual array. Okay, so search value index. I see what they're doing. Okay, it took me a while here. I had to think here. We're just looking at one element of the array. That's all we're looking at. We're looking at one element in the array. So we basically are taking that one element and we're looking at it letter by letter. So we're saying, and how many letters are we going to look at? Well, in this case, we're only going to look at the first 4, because I'm going to type in the word Matt, uppercase M-A-T-T. And so it's only going to go through this. So it takes at each element and it looks at each character. Boom, 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 boom. And if they are the same, so if the first character is the same, it sets it to true. Else it leaves it false. And it keeps going through this loop. Should I have left that? No, it's the same. Let's see how it works. Let's just see how it works real quick. So we come through here. So I'm going to type in Matt. So now it actually goes into here. So it says, no, that's not right. Hold on, let me see if I can fix this. Well, apparently I was wrong. I did need this to start as true and then basically do this until it's false. Okay, so as we go through character by character, if we get a character that they don't match, then I'm going to set that to false and we're going to drop out of that loop and then basically go on to the next name. So that's really what we need to do here is. So let me run this again. Okay, so we've got our array set up. We've got it loaded with all the names. We've got Ava, Chris, Gordon, Matt, and Rose, and Giovanni. Okay, so we've got 6 elements. We've got 6 names. I'm going to type, I'm searching for Matt. Okay, I click OK. So now we go into the search routine, and it's going to go one by one. And it's looking. So here's the array element Chris, Gord, and here's Matt. So we find it. We go through. And it basically comes out the end, that name matches the following element, Matt Hoyle. Okay, so I could even do this. I could run it again. I could type in G-O-R. And it said that name matches the following element, Gordon Pike. Okay. Now, one thing I don't know if I ever told you about this, but if you basically create an assignment, or I think it's a call. Right here, we could actually say clear console. And what that will do is that will clear this console every time you run it. So if I were to rerun this again, notice it clears out the console right here. I could type in AV. So we already have a found going on. It says that name matches the following element, Ava Fisher. Okay. Okay. A little tough lesson for me, but I understand it now. So, okay, so every time you save this, it creates a backup, which is good. Okay, so we kind of get the gist now. And the only problem is, now if we look here, they are using a contains. So they're expecting the contains to be a built-in function, and I had to write this one. So here's what you can actually do. You can actually take this contains and do this. I'm going to shrink it down. You can actually grab this and do a copy and a paste into your program. So if you need it contains, that's basically how you would use it. Okay. Okay. Processing the contents of an array. So in this chapter, you've seen several examples on how loops are used to step through elements in an array. There are many operations that can perform on an array using loops. This section examines several such algorithms. Totaling values in an array. So once we have a bunch of numerics in our array, we can then go through and total all of those to basically get a grand total. So I've set my total equals 0, I've set my index equals 0, in our case it's going to be 1, while index is less than or equal to size minus 1. Again, that would just be for us size. Set the total equals total plus the array index. We set one to the index. So basically, we take each element and add it to the total. Add it to the total, add it to the total. Pretty simplistic, not too bad. So if we take a look at 8, 9, which is basically exactly what they're doing here. I can never seem to grab that corner. Yeah. Okay, so I've got my size. I keep forgetting to do this when I created this. Whoop. I needed to basically create my array called numbers, make it equal to the size, and initialize it to 0. And we will call it integers. Okay, so I set my first element to 2, then to 4, 6, 8, and 10. I set my variable total equal to 0. I set my index equal to 1. I go into my for loop. I'm going to do this until index is greater than size. If it's not, I'd say total is equal to total plus number of the element of that numbers array. I add 1 to index. I said the sum of the array is total. Okay, so 2 and 4 is 6, and 12, which 20, and then so it'll be 30, right? I'm guessing 30. So we run it. $12, $20, and $30. The sum of the array is $30. So pretty cool. Pretty cool stuff. Averaging values in an array. Now this is just going to be like totaling, but we're going to take out one more step. We have to know two things. We have to know the total, and we have to know how many elements. And we should know both of those because why? We basically know how many elements in our array. So let's take a look at 10. So we've got size. Oh, frustrating. Scores. Size equal to 0. Oh, needs to be, come on, 0.0 because that's a real data type. Okay, so we load 2.5, 8.3, 6.5. Okay, so we got 5 elements. We load those. We then got our total, which is real. Our average, which is real. Found equals false. Index, I don't know why I have found in there. We do anything with found? It must be a leftover from something. We got our index equal to 1. We go into our while loop. It's probably a for loop. I'm finding all kinds of problems. Okay, we're going to do this until index is greater than size. Total equals total plus scores index. Okay, so basically this is the same exact thing as we saw in the previous example, except this time we're using real numbers. Except now we say average is equal to total divided by size. And then the average of the array of elements is average. Okay? Pretty simple. So right here, I know how many elements I'm going to have in my array because when I declare my array, I have to know that numeric value. In this case, it's the constant. And then down here, we just take the total, what we basically did inside of our loop, and we basically divide it by the number of elements in the array. So I run it. There's our total, keeps growing, keeps growing, keeps growing, and boom, our average is. Now again, I could have done this as well. I could have put, wrong one. I could have said set precision to, let's make it 2 decimal places. So it'll round to 2 decimal places. I'm also going to put a clear console up here. And save it and run it again. The average for that is 5.30. Okay. Okay. So let's find the highest value in an array. So we've got our array. It's going to be filled with some type of numeric value. Now I want to find the highest. So how do we do that? So let's take a look at 811, and and then kind of step through it. So here's how it works. So again, I keep forgetting to create my array. Okay, so I have to create my array before I can use it. So okay, so I've got my size equal to 5. I create my array, then I load the array with 8, 1, 12, 6, 2. Okay, now I set highest equal to 0. So I'm sorry. I create a variable called highest, initialize it to 0.0. So I create that, then I take the first element of the array and load it into highest. So right now we're going to say the first element is the highest numeric value. Now notice I'm setting my index equal to 2. Why am I doing that? Well, since I already have the first element in highest, I don't need to look at number 1. So I'm going to start with number 2 and continue on. And so I go inside of here, so I'm going to do this until index is greater than size. And this could be a for loop, by the way. It doesn't have to be a while. And it says, if the numbers array at that element is greater than highest. What's in highest right now? Number 1. So index right now is 2. So if that element is greater than number 1, I'm going to say highest is equal to numbers index. Okay, so it's very simple. I've got this variable called highest. I load the first element into it. I look at the second element. If it's higher, I load it into highest. I look at the third element. Is it higher? No. I look at the fourth element. Is it higher? No. I look at the fifth element. It's higher? Oh yeah, it is. I then load it into highest. I look at the sixth. It's not. So now when I get done, whatever's in highest is going to be the largest value that was in there. Now what if they were equal? Doesn't matter. Since it's not greater than, it won't put it in there. Then at the very end we say the highest value in the array is highest. So it's very, very simple. So if we look, we've got 8, 1, 12, 6, 2. So we pretty much can see that 12 is going to be the highest value. So I'm going to slow this down a little bit so we can kind of see it work. We see it load the array. So it comes in. Now it's going to loop through here. So highest has 8 in it. It goes to the third element. Oh, 12 is now the highest. The 6, no, 6 is not higher, 2 is not higher. So now when it gets done, it's going to say the highest value in the array is 12. Okay, so it loads 8 in highest, and then it starts at 2. Is 1 higher than 8? No. Is 12 higher than 8? Yes, so it puts 12 in highest. Is 6 higher than 12? No. Is 2 higher than 12? No. So when it gets out of the array, what is in this variable called highest? 12. We could do the same thing with going just the opposite, and that is we're now looking for the lowest. Okay? I have to create my array before I can use it, even though Raptor allows it. Okay, so same exact thing. I've got 8, 1, 12, 6, 2. Okay, and then I've set lowest. Well, I don't know why it's set to real. I say lowest is equal to the very first element in the array. Again, I start with index number 2, and I go through my loop. I'm going to do this until index is greater than size. If numbers, the array, if the element inside of numbers is lower than lowest, I'm going to change that number, put it to lowest. So it's doing the same exact thing, except now we're looking for the smaller number. And then we can basically look. Now, if we go through here, I can see that 1 is the lowest number. So again, we run this guy. So there's my array. We can see it being loaded. It loads lowest with 8. Then it goes through. 1 is lower, so it basically throws it in there. Is 12 lower? No. Is 6 lower? Is 2 lower? No, it's not. Then it basically drops out. And it says the lowest value in the array is 1. Okay? Simple enough. So a great way to, so we've seen how to search an array. We can see how we go through an array and total them. We can see how we can go through and get a total and divide by the number of elements to get an average. We can then go through and search to see which is the highest, which is the lowest. Copying array. Now, copying array is you would think I could just, in a regular programming language, I could just say copy the array. Well, I really can't do that. What I have to do is actually, well, let's just take a look at what I'm talking about. Is I have to actually create an exact duplicate of the array. Frustrating. So we got an array, we set it with 2, 4, 6, and 8. I then, and 10, because there's 5 elements. And then I say get total. Is this, what did I do? Is this even right? $13. Apparently it is. Okay, so let's take a look at it again. So in this case, we basically we're calling this function called getTotal, which is basically we bring in numbers, we bring in the size, and then we are outputting total. Okay, so we've totally set to 0. We have index set to 1. We go through this for loop, and we total the numbers, and then we basically spit them back. Okay, so that's really all we are doing. We aren't copying an array. I thought we were copying an array. Oh, pass an array argument as a function. My bad. So here's what we did, is we passed the array to a function. Remember, we can't do functions, but let's pretend it's a function. I pass it to a function and said, you total up the array for me, and then give me that total back. And that's basically what it did. We passed the numbers and size and total, and then it basically went through and totaled them all up. Okay, one thing I want to show you here is I actually modified this call procedure. We've got size equals 5, so that's how we declare our array, is by using that constant. Now come down here. I used to have get total, and I would pass in numbers and total, size and total. I don't need to pass in size, and here's why. I'm going to go over here to get total. So I bring in numbers, I spit out total, I've got total. Now I'm going to create this variable called num. Num is set to the length of numbers. Now, if I use length of on a string, it tells me the number of characters in that string. If I use length of, again, this is a built-in function. If I use the length of function on an array, it will tell me the number of elements in that array. So there's no need to pass size. If I just pass the array, it will tell me, I can use the length of to tell me how many array elements there are. Okay, so basically get me the same exact thing. Notice num is set to 5. How did it get that? It basically knew how many elements there are in that array. So it's going to go through this 5 times to get the total. You can see it total 20. Comes through the 5th element, adds 10 to it, it's 30, and basically spits that back and says the sum of that array element is 30. Okay, so there's no need to basically pass size. When I can just basically pass the array, I can get the size of that. I know how I need to do that. Now, one thing I do want to try, I wonder, do I even need to do that? Can I just do that right here? Can I just say length of numbers? Will that basically work for me? I'm going to get rid of this guy. So do I even need to create a variable? So let's try it. Work perfect. So I don't even need to do that as well. I can actually just say, do this until that is greater than the length of the array. So that's pretty cool. Pretty cool stuff. Okay, so let's continue on. So basically the point of this program was to show how we can actually pass an array to a called procedure or function. So here's another processing array. Is Dr. LeClaire gives 4 exams during the semester in her chemistry class. At the end of the semester, she drops each student's lowest score before averaging the scores. So basically, here's what we got to do. We're going to read the student's 4 test scores. We're going to calculate the total of those scores. We find the lowest score. We subtract the lowest score from the total. This gives the adjusted total. We divide the adjusted total by 3 as opposed to 4, and this is the average. We display the average. Okay, so there's a lot going on here. Whoop. There's a lot going on here. So let's take a look at it. So so here is our size, which is our constant. Here is our test scores array. We set it to size, initialize to 0. We've got our total, which is also a real, and that should be 0.0. That should be lowest score should be a 0.0 as well, and average should be a 0.0 as well. Okay, so we've got get test scores. So over here we're basically utilizing this to get the test scores, and we are going to load them into the array. Okay, again, we're passing in size. We do not need to. because here's what we can do. We can just basically say so we really don't need size, so we can actually get rid of that. What did I just do? In size, out test scores. I do need size, don't I? Or do I? Do I need test scores? Do I need size? No, we know the size when I come down here and call it. Yeah, I don't need size. Okay, so I gotta fix this first. Let me do that. I'll be right back. Okay, so I went in and modified this so that we are no longer passing in. Whoop, let me change this. I'm no longer passing size. There's no need to pass size to any of these called modules. If I'm passing the array, we already know the size. Okay, so we've got our test scores. We've created our test score arrays, we've got our total created, we've got our lowest score variable created, average created, and then we call get test scores. So get test scores, we basically set our index to 1, we've got a for loop. We're going to do this until the index is greater than the length of test scores. Again, length of test scores is the number of elements in the array. We ask the user to enter a test score. That's all it does. We come back, so once we've done that, we then get the total. So same thing, we pass on test scores, we're going to pass back total. Here's our index 1, we set our total equal to 0. We then loop through, here's our index. So we're going to do this until the index is greater than the length of scores, again the number of elements. We basically add each test score into the total. Okay. Then we say get lowest test score. Again, we pass in test scores and lowest score. So what it's going to do is it's going to basically pass in test scores and it's going to pass back the lowest score. So we got lowest set to 0, index set to 2. Why do we set it to 2? Because we take the first element and we put it into lowest. And now we're going to go through this for loop starting with element number 2 and compare it to see if it's lower than the previous low score. If it is, go ahead and set lowest equal to that score, and then we basically increase the index 1. So once we get done there, the lowest score is set to lowest. Okay? I don't know why we have lowest in here. We could have just had lowest score. Yeah. Why don't we just do that? Where we don't even need this guy. Don't even need to do that because we've already got it set. Okay? So we don't even need that guy. Okay. The less we need, the better. Okay. So when we get to this procedure, we will have passed back the lowest score. So we come down here, now we say average is equal to the total. Before we go on, I got to take total is equal to total minus the lowest score. Then I'm going to say average is equal to the total divided by size minus 1. Because again, we're talking about 3 tests. We took 1 test out and I'm going to take the average. The average of the lowest score dropped. The average with the lowest score dropped is the average. So let me go ahead and run this. It's going to ask for each test score. Oh. Let me get back to you. Okay, I found my problem. On my get test scores, I had test scores set as output only. It's basically input and output because we're passing it to them with the number of elements, and all zeros by the way, and then we basically fill it and then pass it back. Okay, so that's basically where I had made my mistake. Did I need to do the same thing here as well? Test scores is just input, right? Get lowest is just input. So just get test scores needs to be input and output. Okay, so I run it again. Get test scores. And so now we're going to go through and total all of these, and notice my test scores. I got 89, 99, 76, and 23. So now we're going to need to find the lowest. And what did I do wrong here? I'll get back to you. Yeah, I remember when I changed lowest to lowest score, I forgot to change it in my check here. So let's try it. So let's continue on. So here's my test scores all set to 0. So they're all loaded. Now we need to basically total them, so we get them all totaled. So here we've got our total. Now we need to find the lowest score. There it is, 28. So we subtract that from total. Then we come through and we divide by 3, because it was 4. We divide by 3. This is the average of the lowest score dropped is 88. So notice my lowest score is a 28. That would have really brought it way down. So it worked out pretty good. I found some bugs. Well, I tried to make it more efficient and found some bugs. Anyways, but you can kind of get the gist on how we can utilize arrays, and then we could utilize some of the functions like length of. Instead of passing in size, how about we just use length of? Okay. Okay, parallel arrays. Parallel arrays are needed because since an array is basically a variable. So let's say I need to know. So here's the case. I have students and test scores. I have student names. Well, I can't create an array that has strings and integers in them. So what I have to then do is create what's called a parallel array. I've got an array called names, an array called test scores. If there's 15 elements in the array here, there has to be 15 over here. And the first element of this array matches the first element of this array. So whatever name's here matches that test score in the other one. So that way they're parallel. So each element of each array matches. Okay, so if I have Bob, Sue, Jim, first one's Bob, the first one over here is Bob's test score. Next one's Sue, next one's down is Sue's test score. Jim, and then next one down is Jim's test score. Okay. I don't like this example because they're using names and addresses. Those are both strings. We could combine those. Again, I would rather have that be two separate variable data types. So let's take a look at this one here. So in this chapter, we had 8.4. Megan asked you to design a program and ask you to enter her hours worked by each employee. Okay, so here's what we're going to try to do. We're going to try to basically, instead of now having employee 1, employee 2, employee 3, we're going to basically have the employee's name. So we're going to have two arrays. So let's take a look. So here is our a constant size. Here's a names array. It's set to 0. Why is it set to 0? That should be 2 double quotes. Hours, that's set to 0 as well. And here's pay rate, here's gross pay, and here's index 1. Okay, so this is basically going to be a for loop. Okay, and this should be 0.0, 0.0, and is hours really? I guess you could work 0.5 hours. Okay, so we're going to basically do this until the index is greater than size. Enter the name of the employee. We put that into get names. We put that into the names array. Then we get the hours worked by that employee. We put that into hours. We increase the index. We can go around. So once we get to that, we're going to have all the names and the hours for each employee. Then we say get the hourly pay rate. And then we set our precision. We got our index again. And here's where we basically go back into another loop. It's another for loop. Again, we set our index set to 1, and we say gross pay is equal to pay rate times the hours for that employee, and we put the name. We say name $ gross pay. Okay, so we're going to say the name and how much they made. Okay, so because we're getting the hours for that employee multiplied times the pay rate, and then we say the name and the gross pay. Okay, so we run it. Is Bob, Sue, Jim, and Mary. Wow, did I screw up? I think I screwed up. Okay, hold on. I didn't read each one. So, okay. Oh, the name of employee 1 is Bob. Hours worked by that employee. That's where I screwed up. 40. And there's the name of Sue. She worked 42. And here's Jim. And he worked 36. And Bill, he worked 43. Hourly pay rate is 12.75. So Bob made $510, Sue made $535, Jim made $459, and Bill made $548.25. Okay, so pretty cool. Pretty cool. Parallel arrays. Each element in the array matches the other one, so that because that way there we can combine a string and, in this case, real data into one. Okay. Now, two-dimensional arrays are kind of a strange beast. Probably the best way to compare them is a Excel spreadsheet. We have columns and we have rows. And so if I want to have the same data, so let's say each one of these rows represents one person. And now we have 1, 2, 3, 4 test scores per student. Well, I could create what's called a two-dimensional array. Now to create a two-dimensional array, we are going to basically do this. So let's just see, can we just bring up, yeah, let's just take a look at 16. So in this case we have a constant called rows. It's going to be set to 3, and we're going to have a constant called columns or calls and set to 4. Now notice when I create my array, it says the name of the array is values, and I set it to rows, comma, calls. Notice, so this is a two-dimensional array. So there's going to be 4 columns for each row. I set row equal 1 and call equal 2. So I create a variable called row, set it to 1. I create another one called call, set it to 1. And then I'm going to loop through. I'm going to loop. Now, this is a loop inside of a loop. I'm going to do this until row is greater than rows. And then I'm going to have another loop inside of that, call is greater than calls. I say enter a number, get values, row, comma, column. I add one to call. Okay, so we're going to loop through this until we basically get done, and then we add one to row, and we go back and do this all over again for each column. Okay, so right here we're on row 1, column 1. We add one to it, come back around, now it's row 1, column 2. Come back around, it's row 1, column 3. Come back around, row 1, column 4. Come back around, oh, we drop out of that loop. We add one to row, we come back and do it again. Now it's row 2, column 1, row 2, column 2, row 2, column 3. Okay, you kind of get the gist there. So we got a loop inside of a loop. We reset the rows. We go back and through those loops again, and we are going to put the values for each row. Okay? Put value row, and then we basically say row equals row plus 1. Okay, so very simple. I'm going to input them and then get them back. Okay? So I run it. Enter a number. I'm just going to make this easy. So there's the numbers, but it would really be nice if we could have printed them sideways. So it would have been 1, 2, 3, 4, 5, and so on and so forth. Yeah, we could probably have done that. Yeah, Raptor wouldn't let us do that, but we would actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, because there's 3 rows and 4 columns. So that's really how it should have printed out. But yeah. You get the gist though. So now we're going to use a two-dimensional array. So here we basically have Unique Candy Inc. has 3 divisions. Division 1, which is East Coast. Division 2, Midwest. And Division 3, which is West Coast. Sales managers asked you to design a program that will read as input each division sales for each quarter of the year and then display the totals for all the divisions. This program requires you to process 3 sets of data. The sales amounts for Division 1, Division 2, Division 3, and then these sales of data consist of 4 items. Sales for quarter 1, quarter 2, quarter 3, and quarter 4. So we basically are going to have 3 rows, 1 for each division, and then columns, 1 for each quarter. So let's take a look at that. So I've got rows, columns, here's my total, here's my array, a two-dimensional array. I'm going to say that this program calculates a company's total sales into the quarterly sales amount for each division when prompted. I initialize my row and columns, and then I go into my loop. So this is just like the previous one, except instead of names and whatever the columns were, we're going to have divisions and quarters. And so the great thing about this loop is this. At any time, when I grab row, I'm actually talking about division. When I'm talking about column, I'm actually talking about quarter, which is probably what I should have renamed these two, by the way. Yeah, I should have called them division and quarter. Hold on. Let me change it. Okay, so I fixed it so it's a little more understandable. Instead of calling this row and call, I call it div and QTR for division and quarter. So it makes a little more sense because our rows are equal to the divisions. So Again, come in here. I'm going to do this until division is greater than rows. I'm going to do this until, and so inside of that loop, I'm going to do this until quarters are greater than columns. And then I say division, whatever row that is, quarter, whatever quarter that is get sales, and I throw it into that particular multidimensional array at that position, at that row, at that column. Then I add one to quarter and come back around and do that again for all 4 quarters. Once I get through with that, I go to the next division by adding 1 to div. I reset my quarter and come back around and do it all over again for the next row. And then I reset my 2 divisions, and I basically go through the loop again. This time I'm adding totals for each quarter, and I get a grand total. Okay. Where am I blowing up at? Ah, there I am. Right here. There's probably another place I've missed as well, but we'll see. Okay, so run it. Division 1, quarter 1. We'll say $300. $300. We'll make this real easy. $300. Whoop. And $300. Division 2, quarter 1 is 200. 200. 200. And 200. Division 3, quarter 1, 100. Quarter 2, 100. Quarter 3, 100. Quarter 4, 100. And it basically has a total. The total company sales are $2,400, which is basically right. Okay. Now, I think this book talks about multi-dimensional arrays, which is where we can basically get into 3 or more, and those get kind of scary, but they're possible. They really get kind of tricky, and by all means, if it's ever needed, by all means use them. We may have a student that has maybe test scores. Instead of test scores, maybe there's an A and B test score. So that would be 3 dimensions. So I got each row, and then a column has 2 sections inside of it. So maybe 4-dimensional array. Woo, boom, explode your mind. Okay, so I think that's it for this chapter. Arrays, very, very powerful, allow us to do a lot. By all means, utilize them wherever you can. They are utilized today. In fact, when we start getting into OO, you're going to start seeing other things that are array-like, but once you have the array concept down, it basically will work for you. Okay, we'll see you next time.